Hello and welcome to Yeyu Lab. Today we will dive into implementing function calling with the tiny Llama 3.2 models, especially the 1B model. While the medium-sized Llama 3.2 models like 11B and 90B excel at complex vision understanding, these smaller models are poised to shine in a different domain on-device applications. They are lightweight and perfectly suited for portable devices. So when you look at their blog post, you will see that the lightweight 1B and 3B models are highly capable with multilingual text generation and tool calling abilities. So to truly maximize their potential in edge AI, we need to move beyond simple chatting user cases to control actions and interact directly with external system or appliances by function calling capability. Function calling is one of the most practical approaches alongside retrieval augmented generation or RAG to bring language models to life in the real-world applications. By defining specific functions and their corresponding schemas, we can guide the model to generate structured JSON output that directly trigger actions. This technique opens up a wide range of possibilities, including database query, API interactions, device control, as we will demonstrate in our smart home example in this tutorial. Flagship models like Gemini, GPT, and Cloud popularize the concept of function calling within the context of their models. In this framework, developers define function, and the model, when appropriated, prompted, generates JSON objects containing the arguments needed for the calls needed to call these functions. Initially, effective function calling often requires model especially fine-tuned for this purpose. However, with the advancements in the general reasoning capabilities of models like Llama 3.2, 1B or 3B, and with the assistance of the prompt technique tools like the Instructor Library, it's now possible to implement basic function calling effectively, even the base model that haven't been fine-tuned for this task. So in our next code walkthrough, we will see how we can leverage the tiny Llama 3.2 models to perform function callings to make it more interactive with the outside system. So to extend this function calling to more base models, we can use this Instructor Library. Instructor leverage Pydantic, which is a robust Python library for data validation and parsing to define, validate, and document the expected schemas for function arguments. This tool ensures that the model's output is correctly structured and can be used directly to invoke the corresponding functions. Structure streamlines the integration process by offering a familiar wrapper around existing model APIs. For example, using the Instructor from OpenAI allows you to utilize the standard OpenAI API calls while seamlessly incorporating Instructor's structured output features by providing the response model in its completion method. This design reduces the learning curve and enables developers to quickly add structured output capabilities to their existing projects without significant changes to their code base. Now let's dive into the code examples to see how this works in practice. So we will start with a straightforward financial scenario and then move on a more practical smart home control example. For the financial function, we can define this function and its schema using Pydantic models in the Structure library. By providing this schema to the Llama 3.2 1B model, we can prompt it to output the necessary arguments in a structured JSON format, which can then be used to call our function and perform the calculation. First, install the Python packages including OpenAI, Pydantic, and Structure. The OpenAI will be used to call the OpenRouter's OpenAI compatible API. Due to the size of the Llama 3.2 1B, the model will be very easy to be deployed on a cost-effective environment with not so much memory required. But to make this demo neat, I will use a free inference API from OpenRouter, which works as an online inference proxy for various models. In the code, let's import the instructor, Pydantic components, OpenAI, and load your OpenRouter's API key. Here we define a dummy getRevenue function, which simulates the fetching revenue data, which takes the financial year and company name as input and returns a placeholder string about the revenue data. So it will reply the revenue for a company in a specific financial year, $1 billion. Then we will define Pydantic models. The function call specifies the function's name, getRevenue, and its arguments. And following that, the arguments are defined in the structure of function arguments derived from Pydantic's base model, and define the financial year and company as its arguments. The function call model rebuild is to rebuild the function call with the additional function arguments structure be built. Moving forward, we should initialize the model client. The initialization here is using the OpenAI's client using structured from OpenAI and connecting to OpenRouter's endpoints and enabling the JSON mode for structured output. Now let's call the model. This calls the Llama 3.2 1B free model from the OpenRouter inference service and specifying the function call structure as a response model to ensure the structured output. The message here provides the system message that you are an AI assistant that generates function calls and based on user requests. And the user request is get the revenue for Apple in 2022, which provided the company name and the year. So let's run the code. Okay, you will see that the function result has a structure that follows our expectation, that including the name of function getRevenue, arguments including the financial year and company name. So knowing that the function structure is properly generated, finally the code needs to execute the function. So let's add more code to check the returned function name, and if it's matched, executes the function with the arguments provided by the model. Let's run again. Okay. You will see that the final output from the executing the function generated by the Llama 3.2 1B model is successfully done. The revenue for Apple Inc. in 2022 is $1 billion. So that's exactly what we expect for the output from this function executing. So does it surprise you that even the 1B model of Llama 3.2 can complete such a function call task? Let's go through another more interesting example. The second example of this demonstration will be a more practical application of function calling, controlling smart home devices. We will define functions to simulate setting the temperature and toggling lights, and then use Llama 3.2 model and instructor to press user commands and execute the responding actions. So the basic code structure is very similar to our last demo. Instead of single get revenue function, we now have the set temperature and toggle lights function, which demonstrating how to handle multiple functions within one single application. So we have to define the name in the function call class with a list of function name, and in the function arguments class we define the temperature and state with optional type because they are not required every time. When user required set the temperature will be used, and when they need to control the lights, the state will be used only. And here we are going to try the Llama 3.2 3B instructor model on the Open Router platform. And for the user systems, you are an AI assistant that controls a smart home system, generates appropriate function calls based on their user requests. And this code will simulate a series of user commands to demonstrate the typical smart home control functionality. This showcases how different user requests can trigger different functions with different arguments. So let's run the code. So let's see the responses. User said, "Hey, can you make the living room a bit warmer, like 22 degrees or so?" The system responds, "Temperature in living room set to 22 degrees." The user said, "It's too bright in here, turn off the bedroom lights please." The system responds, "Lights in bedrooms turned off." User said, "I'm heading to the kitchen, can you turn lights on for me?" The system responded, "Lights in kitchen turns on." The user said, "The study is a bit chilly, set it to 19 degrees, would you?" The system responded, "Temperature in study set to 19 degrees. Looks all the user messages have been well converted to the system command. Although the functions defined in this tutorial are all placeholder strings, imagine you have a real API for financial data retrieval or an actual hardware interface to control your home appliances by sending commands. Connecting these interfaces to your function call app will undoubtedly create value for automating people's life, not to mention that the cost of running the open source Llama 3.2, 1B or 3B model is very, very low. That's all for today. For the tutorial and the source code, you can find the link in the description below. Don't forget to like, subscribe and hit the notification bell. Keep innovating, and I'll catch you in the next one.